For want of a nail, the shoe was lost. For want of a shoe, the horse was lost. For want of a horse, the rider was lost. For want of a rider, the message was lost. For want of a message, the battle was lost. For want of a battle, the kingdom was lost. And all for the want of a horseshoe nail. That is a great quote saying. It's been repeated and made multiple times over, but the last time I thought of that, saw that, was in the amazing documentary Fast and Furious Tokyo Drift. Great movie, great documentary. It actually happened. That's real life. Fast and Furious is real life if you didn't know. Welcome back to Boiler Wild, actually. My name is Eric Johnson. On this podcast, talk about boilers and personal development. Always two fun topics. And I started off with that quote, that saying, is because it can be very easy to overlook the small things and say, oh, it doesn't matter. Oh, whatever. That's just, a small bolt. It's just a little gasket. Whatever. It doesn't matter. But in the grand scheme of things, it does matter. Just like in an organization, there's always the motivational bros that are like, oh, I treat the janitor like I treat the CEO. Everybody's the same, whatnot. Yeah, yada yada yada. That whole saying, whatever, has lost its teeth. But yes, you should treat everybody with the same amount of respect. But that janitor for a company is just as important as the CEO on their job duty task. Yes, if the janitor screws up, there's way less consequences, but the CEO of the company only functions well because the janitor is doing their job well. And, what this looks like is if the CEO were to come in and walk into an office and the floor is dirty and there's a coffee stain on the floor and there's trash overfilling the trash can and the counter's dirty and there's no coffee making supplies. Now that CEO could be in a bad mood. They could get out of the right type of frame, and now their 9 a.m. meeting for a $10 million contract for the company goes bad because they weren't in the right headspace. That's an extreme example, but, if the floors aren't clean, if the bathrooms aren't clean, if the desks aren't clean, the environment in which people work in really matters. And you can't say, oh, the janitor, like, that doesn't matter, but the people who are in sales or make all the big decisions, they matter. Well, if you don't have anybody to fulfill that sales that you made, or somebody to, wash the windows to help somebody, look outside, like, that's the ecosystem of a company. And that, sweeping the floor matters just as much as packing product in boxes. And both of them are not normally looked at the same. Some people will look at themselves and be like, oh, I'm too good to sweep the floor. That's beneath me. I'm senior vice president of whatever. I don't do that. And then you can go into the other side of it where the leaders are servant leaders and they serve the people who work with them, work for them. And, you find the CEO, the senior vice president, whoever, sweeping the floor with the warehouse workers. and chopping it up with them because he wants to learn more about them and get more their ear on the ground about what's happening in the warehouse and better understand what is going on and give them some perspective about whatnot. And how they do that is they sweep the floor with the warehouse workers once a month, and they maintain that relationship, and they also learn what's happening, because if the warehouse workers aren't doing well, if there's inefficiencies, that may not get translated up to the top of a company, and everybody just wants to sweep it under the rug, and those inefficiencies can kill you. Just like for want of a nail, the message didn't get delivered because the horse didn't have a horseshoe, and the kingdom was lost. How this translates to boilers outside of the company system, every single company has a system of people, a hierarchy, and you fit somewhere in that hierarchy. And what's above you, what's beneath you, yes, you have a job title, yes, you have job responsibilities, but you need to be willing to step up to a task or step down to a task, depending on what that task is. You're not too good to do task. Now, if the CEO spends all their time sweeping the warehouse floor because there's nobody to sweep the floor, then their job responsibilities aren't getting done, and now you have other problems. So there is a time and place, but the best people are the ones who will do what's required when it's required. So how this translates to boilers. So when you are working on a boiler, especially during an annual shutdown, the boiler shuts down, you open it up, you drain it. We're talking about steam boilers here. This does apply to hydronic boilers, but really only probably traditional ones. Maybe larger hydronic boilers. The smaller ones are a little easier to work on. Not as many gaskets, not as much maintenance, but a steam boiler, you shut it down, say it's for a process facility, and you have to be in the frame of mindset that everything that I do to this steam boiler, like, will this last for 1 year? So if you pull out a handhole in the gasket and the old gasket gets stuck on the surface, and you peel off the gasket and there's like particles left on the surface, do you go, it'll be fine, I'll just smash down the new handhole gasket? Or do you go, oh, well, everything matters, let me scrape up that gasket to make sure that the metal surface is clean, so that the new handhole gasket gets put on the handhole and correctly seals, and I don't have to clamp it down, or when we're filling the boiler, that we have less a chance of a leak. Same thing with like fireside gaskets. Am I making sure that the gasket is sealed properly, that it is applied properly? Am I making sure the door is sealed? Am I making sure the bolts are all in good condition? Are the nuts in good condition? Do any of the bolts need the threads chased on them? Any of the door studs and all that? Am I looking around the burner tile? Are there leaks around the burner tile? Do we have issues with the burner? Are there any vibrations on the burner? Is there any wear that could happen and cause a problem over the next year? And all these little things add up. And ideally, I know a boiler has like, the daily, weekly, monthly, job responsibilities. But those responsibilities, you're probably never opening up the actual pressure vessel. So most steam boilers, you close them up and they don't get opened for another year. So when you are opening up the boiler, you're looking at low water cutoffs. You're looking at low water cutoff probes. Are the probes in good condition? Am I cleaning the probes the whole way? Are the threaded ends in good condition? Making sure that the porcelain isn't broken. Are the ends of the wires in good condition? One little wire end, it's just a little, 50-cent crimped wire end. Well, that can be enough to shut down a boiler, and now you've lost, say 4 hours of production by the time somebody gets there and fixes it. 4 hours of production, I don't know, let's just make up another 50 grand. Now that costs the company 50 grand for a little 50-cent wire crimp. So when you need to have this mindset of everything matters, and you have to go through this fine cone list in the frame of the mindset of, I'm not going to be here for another year. Nobody's going to be touching this boiler for another year. At least not the normal maintenance stuff, but the wiring, the internals, the gasket surfaces, this stuff needs to last for a year. And when you frame that mindset, you think differently. Because when I used to, way back in my day when I was young, but when I used to do boiler shutdowns, boiler internals, you look at wire ends for a low water cutoff and you go, it's not that bad. But you can say, it's not that bad, it doesn't quite need replaced yet. But then if I frame my reference of, will this wire end last for another year? Then I'd probably go, well, probably not. Let me replace that. So, then you look at the wire. Oh, this is, high temp wire. It's got a little fraying. It's got a little cracking here and there, but it's still in pretty good condition. It's not cracked through all the way to the insulation. It just seems a little dry. Once again, is that wire? Do I think that wire would last a whole nother year? Probably not. This goes with linkage too. Linkage on, single point positioning systems on burners, linkage burners. You have all mechanical parts, and even on parallel positioning, there are still mechanical parts. Dampers have linkage to connect the blades together and all that stuff. Every system is different, but you look at those mechanical parts and you're like, well, it's worn, but it doesn't, I wouldn't say it needs replaced. So linkage is part of the safety system of the boiler. That is what controls the air and fuel. You don't want to wait till it breaks in order to find out that there is a problem. You always want to be proactive, especially with linkage, but with anything on a boiler. You never want to wait till something breaks if you know it's wearing. And with a linkage, a little ball joint, you may be buying them for $7 to $10, but that $7 to $10, if you just save one service call, it pays for itself. And that linkage joint, you can look at it and see, it's got 50% of life left in it. Well, is that linkage joint going to fail in the next year? Are you going to get to 80% worn? It's pretty hard to tell, but it's easier to tell that you replace it and you go, all right, it's new. I don't have to worry about that. That joint was a couple years old and now it's not going to fail in the next year because I replaced it. If you have the mindset of, it's not that bad, you can overlook items that will fail in the next year or will become problems or lead to service calls. You always have to have the frame of reference of, will this last 1 year? And that really helped me when I was servicing boilers. And that's what I do a lot of training on that as well. Of, when you look at a boiler, it's not like you're looking at a little rooftop air conditioner when you start the air conditioner and you find something's wrong, you just shut it down and you can immediately fix it. With a steam boiler, there are a certain list of tasks that you can do when the boiler is cold and open. Water side's open, fire side is open. The second you close up the water side, close up the fire side, you fire the boiler and you make steam on the boiler, there's now a path. You've now like hit a checkpoint where it is very hard to go backwards after that checkpoint. So if you didn't really pay attention to your gasket surfaces on the water side and now you have a leak on your handhole, and it's not I just need to tighten it leak. It's the old gasket part of it was left on the shell of the handhole surface, and this new gasket will not seat. Well, now you have to bleed steam off the boiler. Now you got to drain the whole boiler again, or at least drain it below the handhole surface. But experience will tell you that if you have a handhole leak, it's always going to be the bottom one. So you have a handhole leak, or you have a manway leak. You have a mud drum manway leak, or you even have a fire tube manway leak, but it leaks at 10 psi, 12 psi, 15 psi. That may seem like a small number, but 15 psi of steam on 100 horsepower boiler, that is a lot of steam pressure, and that is a lot of energy, and you now have water that is over 200 degrees, and you don't just shut down the boiler and quickly cool it off and open the manway and adjust it. That takes hours and hours and hours to get the boiler cool enough to readjust the manway. So taking an extra 5 minutes and making sure that the manway is in the correct position, that the gasket is properly centered on the manway, that the manway plate doesn't have any dimples on it. I remember one time I was at a place and the manway was so pitted, and I essentially brought it to the customer. I said, hey, this manway, this is, one, it's unsafe, but two, I don't think I'm ever going to get this to seal up because it is so pitted. Because I was using like the rubber manway gaskets, the black manway gaskets that most people use. And while those gaskets are soft and pliable, they're still pretty hard. And if you have a groove and like pits in the sealing surface of the manway plate, you can get a pit or groove that goes under the gasket and will leak. And it's very, very hard to seal up. Normally they seal up just with like time and corrosion, and that's why the old one is sealed. But you clean the surface, you put a new gasket on there, and now you have issues with it sealing. So do you get a new manway plate and put it in, at the, assume you have one on the shelf, it's not that you're taking any extra time. So you get a new manway plate. Yeah, the customer pays for it, but you put it in and you don't have issues, or you just take the gamble that when we get this boiler up, to 50 psi, this thing could leak. And you're not being speculative. You're making decisions based on the small things, and you have to have good sealing surfaces for your manway plate. And if the sealing surface is all pitted and corroded, yeah, it's probably not safe. While it may still hold, it's probably not great to reuse, but people will constantly keep reusing them and stuff. But are you making the decision of, hey, if I go a whole nother year with this manway plate, will this sealing surface hold? And maybe not, but a new one would be a lot better. And how you stop a sealing surface from corroding is you don't have any leaks. You get corrosion on sealing surfaces by letting them leak. I've walked into many boiler rooms, and you're like, yeah, what's going on with your manway? They're like, oh, it's just been steaming a little bit the last couple weeks, but we don't have time to shut down, or we can't, we haven't touched it. And that little leak, you get chemical in that little leak, but it ruins the sealing surface of the manway. And now you have corrosion and pitting, and the next time you open up that manway, it's not going to seal as easy. This also applies to like refractory. So it's easy to look at refractory and be, it's fine. Just put a little mud in there, patch it a little here, a little here. And, when I would look at refractory, it's either, there's very few refractory repairs that can be repaired permanently. Refractory just disintegrates constantly, and you have to do your best to keep it from disintegrating. Unless you do like a full rip out or a major patch, refractory doesn't normally like small patches, because these small patches, they don't adhere and bond to the rest of the refractory, and when you heat it up and cool it, that patch normally pops off and doesn't get the teeth it needs to hold. So when you're doing a refractory patch, when I would do those, you got to look at the refractory and say, is this patch, is this what is going to be stopping, the refractory from becoming unsafe? Like, if I don't make this patch, what is going to happen? And yeah, sometimes you only have the option to make the patch and hope it holds and all that stuff. Sometimes, customers don't want to have to redo refractory and whatnot. But when you look at it from, all right, will this patch hold versus will this patch hold for a year? And that's a very different thinking to me. That should be very different thinking to you. Yeah, it may look good to a picture that you post or take of your patch, but what does that patch look like a week from when you fire the boiler again? What does it look like a month from when you fire the boiler again? And that all makes a difference. Same thing with water side corrosion in your DA, water side scale in your boiler. Oh, it's just a little bit of corrosion. Well, that corrosion didn't just happen, magically. You're doing something wrong if you have a DA and you have a lot of oxygen pitting and solids like mud in your DA. You're doing something wrong. What's your steam pressure? And all those little tiny things can affect the operation of the DA. If you are rotting out pipes on your feed water lines, you probably have a chemical treatment or a deaerator issue. May say you only have a feed water tank. You probably need some more oxygen scavenger from your chemical. And that little just increasing the dose of the oxygen scavenger can save, a full boiler retube over the course of a year of not rotting out all your tubes. And those little tiny details are so important. And in the boiler room, everything is a system. Everything's connected, just like basically all mechanical equipment, like your car. Your engine only runs because it has a gas tank. Your gas tank is only there because it's got a frame to hold it. The frame only moves because it has tires and wheels to move the frame. You only have tires and wheels because you have axles, and you only transport in the car because the car has an interior, and it's a system. Same thing with a boiler. The boiler only gets water because there's a holding tank like a deaerator or a feed water tank to get the water. And those holding tanks, they only get water because you have a water supply. And that water supply only supplies the proper water because you treat the water. So you have a water softener, you have an RO system. But all these little things, they all add up to a well-working boiler room. And when you overlook the tiny details and say, doesn't matter, it's just a little leak, especially on like a gasket surface, little leak, whatever, that can lead to larger problems and more expensive problems. And it can be easy to disconnect from problems because, normally you're just an employee or you're an outside contractor and you don't see the money spent. It's not my money. Whatever. You'll get that on these big jobs. But what makes you valuable as a person is the ability to make decisions and care about those small things. You care about the nails that hold the horseshoe onto the horse because you understand that if the horse doesn't have a horseshoe, the horse can't run 100 miles. Same thing with the boiler. If the boiler doesn't have great water treatment, it's not going to kill it over a day. It's not going to kill it over a week. But over the course of a year, you can cause a ton of damage to a boiler without great water treatment. When you open up a boiler, are you flushing the pressure controls? Are you making sure that if you have siphon loops, that the siphon loops aren't plugged or becoming plugged? Are you making sure all the pressure controls work? When you close up the boiler, are you making sure all the safeties and limits work? It's all these little things that if you skipped it in the time, it may not matter. The boiler will still run. Somebody may not know, and it's not always required to, check this safety or look at that or, do this. But in the long run, that will matter. There are plenty of boiler accidents. Everybody thinks, a boiler accident, how does this happen? How does this happen? It's a series of very small, poor decisions. And people may not realize that they're making a poor decision at the time. But when you look back on it and, you're calibrated from a calibration mindset of, what is right and wrong versus what you think is right and wrong in the time, it's easy to make a decision. Let's just jump out that low water. The operator will just watch the boiler while, and make sure that there's always water in the sight glass while we have a new low water cutoff on the way. Like, that's fine, but then the operator goes to the bathroom for 15 minutes, and then when he comes back, the boiler's dry firing. Like, that, it seems like a okay problem and solution at the time. Like, we're intentionally jumping out a switch, but we can't shut down the boiler, but we have an operator. He's going to be watching the boiler the whole shift, always making sure there's water in the sight glass and everything. But then he goes to the bathroom for 15 minutes and he couldn't get a hold of anybody on the radio, and he couldn't hold it anymore. So then he went to the bathroom, but he wasn't going to be the one to shut down the boiler. And now the boiler ran, and during that 15 minutes, it dry fired and caused damage to the boiler. Ran out of water. Like, you would obviously say, well, duh. You shouldn't have jumped out the low water cutoff, but at the time they thought they were making the best decision for what they, thought that the variables had, but the actual best decision is saying, no, jumping out a safety on a boiler is never okay. And we're never going to allow that. We're never going to do that. And that's why we have extra boilers. Or, hey, we're just going to have to run at 70% on our process because we don't have enough steam. But, we have a new low water cutoff coming. We're going to start cooling down the boiler and get this so we can get the, control changed or whatever. Most poor decisions are influenced by money or the lack of losing money, or they're influenced by supervisors that don't understand, boiler safety, and they just are, they're just trying to make their boss happy, and their boss is trying to make their boss happy. It's this chain of command, but nobody wants to take responsibility for all these decisions. It's just, just get it done. I don't care how it gets done. And you have to be the one to put your foot down as the boiler professional and say, no, this is right, this is wrong, and this is wrong. And that's hard to do in the moment, but you have to mind the details. Everything's about details, especially with boilers. You gotta be mindful of your water, the TDS, the total dissolved solids of your water. If you get high TDS, now you get maybe a little bit extra carryover. Now you have a little bit extra water in your steam header, and now you have a little bit more water hammer, and now you have too much condensate, and your traps are overloaded, and then now you have wet steam and your process suffers, and all because your TDS is a little bit high because your surface blowdown controller wasn't working correctly, or you didn't bother to calibrate it or whatever. Like every small problem can blow up into a much larger problem if you're not mindful of it. And if you just have the perspective of, is this going to have a long-term effect? Yes, no. Will this last, a year for, internal stuff on a boiler? Yes, no. Like that changes the perspective versus, will this last another day, or is this fine in the moment? Yeah, it may be fine in the moment, but is it fine for another year? So that's how I always thought. That's how I think. That's how I train and try to educate people about how to think about boilers, how to think about problems, and every single mechanical system. I even with a car, a car will throw a code for some random sensor. Yeah, the car still works, but it's thrown a code and for a sensor, and if you ignore that code, something could go wrong. Like there's this rolling effect of the small stuff equals the big stuff. And nobody scales up their boiler in one day. Nobody corrodes their tubes in one day. Nobody plugs off their safety relief valves from a leak of the seat in one day. It happens over time. And if you don't stay calibrated to what's normal, if you don't understand how things are supposed to work, and you rigidly stay aligned with how things are supposed to be done, then you can get way off calibration, and you can allow unsafe things to happen, and your series of poor decisions can happen over a decade at a time. And it can be hard to understand that you're working in a system of poor decisions if you don't have any calibration to what those decisions are, because it's been so long since a correct decision has been made. Like if it's normal to just jump out of safety on a boiler, we're going to jump out the low gas pressure switch. That's just a minor safety. Like it doesn't really do anything. It never trips. And, you jump it out for 2 days, and then, you shut down the boiler on the weekend. You change out the low gas pressure switch because, it was bad or whatever. Nobody's the wiser. Nobody got hurt. You jumped out of safety. It's fine. That you are instinctively telling yourself and telling other people that it is now fine to jump out safeties, and your brain, you are now thinking, well, there's no consequence to jump out safeties. So the next time somebody says, hey, we just need to jump it out, or hey, can you jump that out so that the boiler can keep running? Your brain will say, yeah, of course we can jump it out, because, the last time I jumped out of safety, nothing happened. So why would anything happen this time? That is how bad things happen. That is how accidents happen. Nobody says, you know what? Today I'm going to go into work and I'm going to cause an accident. Or today I'm going to go into work and I'm going to die because, I'm going to work unsafe. Nobody makes that decision. They just end up working in an unsafe environment, and they're unaware how close they are to a accident until the accident occurs. And there's all kinds of safety professional nonsense that can go with that. But if you if you try to stay calibrated with what is right, what is true, and always mind the small details, you will normally stay on the straight and narrow instead of the wandering path of boiler safety and process safety and understanding what is right and wrong. So mind the small details, especially if you are doing internal stuff with the water side, fire side, and like shutdown stuff, where once you get past the point of no return, you put temperature into the vessel, you put pressure into the vessel. Once you get past that point of no return, it's very hard to go back. And that extra 10 minutes, spending to make sure that pressure control, the siphon loop under it was unplugged, like that extra 10 minutes would have saved you now hours and hours of time of, that pressure control siphon loop is plugged, and now we have to bleed off steam off the boiler and get it cool enough so that I can, unplug the siphon loop or, replace the siphon loop. So that is what I have today. Hopefully that makes sense. Let me know if it doesn't. If it did, if you like this episode or other Boiler Wild episodes, please rate the podcast 5 stars. I appreciate it. If you want to be a guest or have questions, you can email me at eric.johnson@boilearn.com. If you want to be, or DM me on LinkedIn. If you're not on LinkedIn, you should get on LinkedIn. But I appreciate you listening. I believe to episode 28 of Boiler Wild. We're doing this, and I will have guests for you very, very soon. So thank you, and stay wild.